New definition, well, we talked about it yesterday. The normal is perpendicular to the tangent. So here we have our slope idea that you learned way back in grade 10, that perpendicular lines, slopes, are negative reciprocals. So our slope of our normal will be -1 over the slope of our tangent. Or whatever our tangent line is, flip it and make it negative. So if one, is yellow, the other one will be blue. No. If one slope is 2/3, the other slope would be -3 over 2. And all this line is saying is if you ever take anything like that and you multiply it together, can you see that your 2's would cancel out and your 3's would cancel out, and all you'd be left with is -1. And it doesn't matter what numbers I have, that will always happen. So the slope of your normal times your slope of your tangent will be -1. So now we can find the equation of a normal line to the curve, and really this isn't much different than finding the slope of a tangent. So what we have here is we have a parabola. This time our parabola is going down because we start with a negative, it's a cubic, sorry. We have a cubic, and our cubic is yellow. It's nicely highlighted there for you. It's going down from left to right because our initial value is -2. And we have the point 2, -5. I don't even know where that is on my graph, but I'm going to pick that point. And there's a tangent at that point. And what we're looking for is the equation of the normal. So here's the idea of what's happening. What are we going to need to find that equation of that normal line? Same thing we need to find the equation of any line. We're going to need a slope and a point. We already have the point because we know that's 2, -5. So if we can find the slope, we're going to be going quickly and figuring this out. Well, what does our derivative do? Our derivative tells us slopes of tangents. So we're going to be able to find the slope of that green line relatively easily. Because we take our derivative, dy dx, -6x squared plus 8x. We can plug into -24 plus 16. So we find out at x equals 2, our slope is -8. So what's our slope going to be on our purple line? On our normal, it'll be +1/8. Because we can think of this green one as -8/1. So we do the negative reciprocal. Now we got our slope is 1/8. If you want to use y equals mx plus b this time, we know 1/8 is our slope. We know that when x is 2, y is -5. The only thing we'd have to solve for is b. This is 1/4, subtract 1/4 on both sides. You get -5 minus 1/4 is b. -5 is the same as -20/4, so this will be -21/4 equals b. And we can write our equation of our normal is 1/8 x minus 21/4, pending any mental math errors. Example 2 here. Everybody ready? a little bit more involved because the derivative is a little bit more involved. Also graphing it. That first one, I knew it was a cubic, I knew it was negative, so I could draw a picture. This one, I look at it, and there is no graph that pops into my head. Well, I have the square root graph, so I think of that one, but then 5 over the square root graph, and then subtracting those two together, you know, that's the best my brain is coming up with right now, not very good. But I know the domain has to be bigger than 0, so let's think positive. There we go. So there's my graph. And as you can see, I accurately drew it, so it has the 0.1, 4 on there. So I could have a tangent. I have no idea if that is my tangent. And I'm trying to find the equation of this normal. Again, I need the slope of that purple line. I already have my point, so this isn't going to be too much more involved other than the fact that we don't really have a picture in our head of what's happening. How do we find our derivative? Well, we're going to have to take a couple of extra steps here. This is going to be 5 over x to the half, which means when I bring it up to the top, it'll be 5x to the negative half minus x to the half. So we have to take that initial step to change things so that our power rule will allow us to take the derivative. Bring the number in front and subtract 1 from the exponent. And we've got our derivative. They were kind in choosing the value when x equals 1. Because f prime at 1, whoa, that looks like inverse. Here we go. F prime at 1 will be just negative 5 over 2. Because x to the negative 3 halves is the same as having x to the 3 halves on the bottom, which is the same as the square root of x cubed. But when x is 1, that's just going to be 1. Same thing with the second one. X to the negative 1 half, when you plug that value of 1 in there, that's like 1 over x to the half, which is like 1 over the square root of x. And plugging in 1 will just be 1. Negative 6 over 2. We get a slope of our red line is negative 3. So the slope of our tangent is 1/3. So obviously my initial blue graph is wrong. I know you were hoping that it was right. But according to what we found out, the slope of our red line is negative, even though we drew it positive. And then our normal line, which is the negative reciprocal, our slope is positive, even though what we drew was a negative slope. But sometimes just that graph helps you visualize what are the things you need to know and what are the things you know. Now we can go to y equals mx plus b. We know our slope of our normal is 1/3. We have our point when x is 1, y is 4. Four minus 1/3 will be our b value. 4 is 12 over 3. So our b value is is 11 over 3. And we have our equation of our normal.